As you may remember, the solution to a system is the point or points the functions in the system intersect each other. Previously, we have solved systems of linear functions. Now we will solve systems with a linear function and a quadratic function. A linear graph could possibly intersect a quadratic at 2 points. This means that the system has 2 solutions. A linear function could also intersect a graph at 1 point. This would mean that the system has 1 solution. Or a linear function can intersect a graph at 0 points, meaning the system has no solution. For our first example of solving quadratic and linear systems, our system is the linear function of y equals 2x and the quadratic function of y equals x squared plus 3. I'm going to graph both of these functions and see where they intersect. The point or points of intersection are going to be our solutions, or if they don't intersect at all, that would mean that there is no solution to this system. So I'm going to start out by graphing y equals 2x. We know that the y-intercept is 0, so we start at the origin. We then know that our slope is 2, so we do rise over 1, run up 2 over 1, up 2 over 1, and so on. Now, this graph is of course a rough sketch, but if you have graphed correctly, yours should look somewhat like my graph. Now I'm going to move on to the next function, which is y equals x squared plus 3. We start at the y-intercept, which is 3, up 1 over 1, up 1 over 1, and if this were a bigger graph and we could see more of it, it would be up 3 over 1, up 5 over 1, but since I have limited space, this is all I'm going to draw. Just know that it continues past this point. From both of these functions graphed, we can tell that these do not intersect at any point. Therefore, we can conclude that there is no solution to this system. And that's all we need to know. For our first example of solving quadratic and linear systems algebraically, our system is x squared plus 3 equals y, which is our quadratic function, and x plus 3 equals y, which is our linear function. What we're going to do is we're going to use substitution. So we're going to start out by setting these equal to each other. This is because they're both equal to y. Now, once they've both been set to each other, we want to get all of the terms on one side, so we're going to subtract x from both sides. It then becomes x squared minus x plus 3 is equal to 3. We're going to do the same thing with 3 and subtract it from both sides, and then we get x squared minus x is equal to 0. Now that we have a 0, we can factor. With x squared minus x, you can factor out the GCF, which is x. X squared divided by x is x, and negative x divided by x is negative 1. Now that we have this factored out, we can determine the x's of the solutions. One of the x's is going to be 0 because the factor is x plus 0, and when you set it to 0, it still remains at 0. The other factor is going to be 1 because x minus 1 set to 0 is 1. You negate it. Now, we're going to plug in these x values into the system to see what our y values would be. So I'm going to put x into both of the functions, though you only need to put it in one. I personally like to check. so whichever method you would prefer. So it's 0 squared plus 3 is equal to 3. So now we know that y is 3 when x is 0. Now I like to double check, so I'm going to plug it into the second function as well. 0 plus 3 is equal to 3. So now that we know what this point is, now that we know what the y of this point is, we know for sure that this is a solution to the system. Now we can move on to our next solution. We're going to plug y in the same equations, and we know that 1 squared is 1 plus 3 is 4. So y is 4. And so we know that that is another solution to the system. For our second example of solving quadratic and linear systems, it's going to be a little bit more difficult than the first, but it's fairly simple to catch on to, so just follow along closely. My first step in the system is going to be to isolate a variable. I'm going to choose not to isolate x because, as you can see, it has a coefficient and I don't want to deal with fractions. To make it more simple, I'm going to isolate y, which means I will subtract 8 from both sides. I now have an isolated variable, which means I can use substitution to plug it back into the first part of the system. So you have negative 4x plus x squared minus 8 is equal to 24. My next step is going to be to push all of the terms onto one side. So I'm going to subtract 24 from both sides, leaving us with x squared minus 4x minus 32 is equal to 0. You want to make sure that your terms are in decreasing order of power. Not only is it mathematically correct, but it'll help you out in the long run. Now that I have something that's set to 0, I can easily factor out. I'm going to use grouping method, and so I need to decide two terms that multiply to negative 32 and add to get negative 4. These terms are negative 8 and 4. Now that I have these, I can determine the x's of our solutions. I'm going to set it to 0, which means I take the negated version of it, and so it's now 8 and negative 4. These will be the x's of our solutions. Now that I have the x's, I can plug it back into the system to get the y's. I'm going to plug it into y equals x squared minus 8, because I feel that that's the most simple. So follow along here. I'm sorry, it's going to be a little bit sloppy up here, but I'm going to plug it in, which is 8 squared, which is 64, and then minus 8, which leaves me with 56. So that's the y of that part of the solution. So we know this point is a solution to the system. Now I'm going to do the same thing with negative 4. I plug negative 4 in. Negative 4 squared is equal to 16, and then minus 8 is equal to 8. And so this is my second solution. My solutions to the system are 8, 56, and negative 4, 8. For our last example of solving quadratic and linear systems algebraically, it's going to require a lot of steps. But like I said in the last example, it's fairly easy if you follow along. So, as you may remember from last time, my first step is going to be to isolate a variable, but y is already isolated. So that makes things a lot easier for us to begin the method of substitution. So now we have negative 6x minus 2x minus 3 squared is equal to negative 14. Now my goal is to follow the order of PEMDAS. And with order of operations, you always begin with what's inside of the parentheses. So you factor out the x minus 3 squared, and you get x squared minus 6x plus 9. You continue inside of the parentheses, and you distribute out the 2. giving us 2x squared minus 12x plus 18. Now we're going to distribute out this negative right here to make it easier whenever we are combining like terms. So we have negative 2x squared plus 12x minus 18. And we now combine like terms. My next step is going to be to push all of the terms onto one side of the equation, so I have to add 14 to both sides, giving us 2x squared plus 6x minus 4 is equal to 0. Now that I have something that's set to 0, I can easily factor out. This equation here has a GCF. I'm sorry, I've been writing 2x squared. It's negative 2x squared if you happen to write down the wrong number. So my equation is negative 2x squared plus 6x minus 4. I can factor out my GCF of negative 2, and negative 2x squared divided by negative 2 is x squared. 6x divided by negative 2, negative 3x. Negative 4 divided by negative 2 is 2. So now I can factor out even further. I need to find two terms that multiply to get to 2 and add to get to negative 3. These terms are negative 2 and negative 1. Now that we have factors, we can easily determine what the x's of our solutions are going to be. We have to set them equal to 0, so we know x minus 2 is 0 plus 2. That makes x 2. So we know one of the x's of our equation is going to be 2. We do the same thing, and we end up with x is equal to 1, making the other x of our equation 1. Now that we have these points, we're going to want to plug them back into the system in order to get our y's. I'm going to use the part of the system that I find easiest, so I'm going to use 6x minus y is equal to negative 14. So we need to plug that in, so we're going to do negative 6 times 2 minus y is equal to negative 14. Negative 6 times 2 is negative 12, minus y is negative 14. Now we need to, again, move all the terms to one side, so we add 12 to both sides, giving us negative y is equal to negative 2. And we don't want a negative, we just want y, so we divide by negative 1, giving us y is equal to 2. So our first solution to the system is 2, 2. Now we can find the other y to the solution of our system. We know our x is 1, so we're going to plug it back into the same part of the system. And so we're going to do negative 6 times x, which is 1, minus y is equal to negative 14. Negative 6 times 1 is negative 6, minus y is equal to negative 14. Moving all terms to one side, add 6 to both sides, giving us negative y is equal to negative 8. And again, we don't want a negative y, so we're going to divide by negative 1, giving us y is equal to 8. So our solutions to the system are 2, 2, and 1, 8. Simple, right?